I'm Amber Trumfio George, and this is my infiltration STEM activity. So first I define the problem, and then asking questions like what is infiltration, and getting diagrams based on that. Asking questions like how does it affect my area, and using the National Groundwater Monitoring Network interactive map to help me find my area. I looked at different filtration systems. I also looked at each of the materials and how they worked, and how they could also make connections to the natural world, which I then utilized in my model that I created, layering each one of my materials to represent the natural world there. Um, then I constructed my design, and then I tested. So you can see here, as I'm testing the design, I did have to wait a couple seconds in between pouring because some of it was getting caught in the mesh net there. But overall, it did seem to work pretty well, even with just the alum. Um, the water was coming out pretty clear. So at the end, you can see that the water was pretty much filtered at that point of most of the debris. I then wanted to push this a little bit further and see if I could actually filter out food coloring, which to my surprise did actually work. It was a little bit cloudy, but I think it was just the sand at the end. So overall, the infiltration process was successful with the water being observed to be clear after filtration. Areas of concern consist of the debris being trapped in the mesh and causing overflow. But this might relate to flooding that is caused when too much water is present to be able to filter at the proper rate. So assessment of this activity based on the scientific practice continuous assessment tool, I gave it a level 4 for asking questions. It lent itself well to making connections to the natural world and its importance regarding human impact. For planning and carrying out the investigation, it allowed for investigation of materials, connections to local and natural phenomenon. Could be enhanced by not providing any materials. I didn't really utilize mathematics and computational thinking, but you could if you sent the water out to get tested and analyzed ppm, and then utilized various charts in class, and students could graph that. They could also graph the fastest rate of filtration. For example, mine took 7 minutes and 34 seconds. I did find that BJ's will provide free water tests, so that's something that you can do at school to get rates and ppm, and then also graph and chart everyone's in class. For analyzing and interpreting data, the data was provided in the results, but it's somewhat subjective, so having multiple models represented and discussed would have enhanced this. For constructing explanations, I was able to make very tangible connections to the phenomenon and its occurrence with the natural world with physical evidence. So I give that a 4. Developing and using models. So there were limitations that could be discussed and brought up in class, such as the plastic layers, or also just the scale of materials used and how you can make that more like the natural world. But I did think that from drawing to creating the physical model, this was exemplary. Engaging in an argument from the evidence, this would have been better in a larger class, and we could observe everyone's the pros and cons during a class critique, especially if we had quantitative data. Then obtaining, evaluating, communicating information. So several scientific vocabulary terms were introduced to me, like flocculated, infiltration, humus, and turbid, for example. There are many texts that I was able to utilize. There was videos, there was diagrams, and then you could present this in so many different ways, from the video to your drawings and things. So I think this was really good at introducing and communicating information for scientific tests. And again, further extensions could things like the actual water testing there would enhance it. And then this is my citations.